안녕하세요. Today we're talking about graphing exponential functions. Make sure you got this handout before you start. So, exponential functions can be written like this, ab to the x power. Remember that a is a constant, which means it's a number, and it's going to tell us the y-intercept of the graph. So that's the first thing we're going to graph is the y-intercept. B is the base, also a constant, also a number. It could be between 0 and 1, in which case we're going to have decay, which means going from left to right, it's going to go down. If b is bigger than 1, we're going to have growth. So going from left to right, do you think that's going to go up? Or do you think it's going to go down? Well, growth is going to go up. So let's see what we mean by this. So our first example, we have 1.2 to the x. They tell us that a is 1. Where did they get that 1? I don't see a 1. Well, remember, anything times 1, you can multiply anything by 1 and nothing happens. So our 1 is hiding there. So a is 1, that's our y-intercept. B is 1.2. Since 1.2 is bigger than 1, we're going to have growth. So we should see a graph that goes up, which is exactly what we see. So to graph this, what they did is they put a dot at 0, 1. So our y-intercept is at 0, 1. And then they just had an arrow, they had it going up to the right. And remember, we have an asymptote right here. So don't forget, asymptote at y equals 0. That's what we're always going to have. Until you get to algebra 2, you're going to have an asymptote at y equals 0 for any exponential. And remember, y equals 0 is the same as the x-axis. So that's why we drew our graph like this. Here's another example. A is 10, so we put a dot at 0, 10. And then B is 0.6. Since 0.6 is between 0 and 1, we know we want decay. So we want something that starts here and then goes down. And remember, guess where our asymptote is? That's right, our asymptote is right on the x-axis. So once again, asymptote, yes, funny word, at y equals 0, which is the same thing as the x-axis. Again, for us, for Algebra 1, we're always going to have that for exponential functions. Algebra 2, you'll find out that you can have asymptotes in different places. But for us, we're just going to leave it on the x-axis. All right, last thing, let's find the domain and range. Well, that's really easy because, again, in Algebra 1, our exponential functions, if it has an arrow on both ends, the domain is all real numbers. And again, we said the asymptote is at y equals 0. And notice the graph is above that. So for Algebra 1, our range is always y equals 0. And you'll notice for the other graph, we had the same domain, same range. Because in Algebra 1, all exponential functions are going to have this domain, this range. Again, I can't stress this enough. In Algebra 2, that will change. But don't worry, that's in a year and a half. So for now, we're stuck like this. Let's go to some examples that have not been worked out for us. All right, we need to figure out if it has growth or decay, then graph it, and then state the domain and, sorry, this got cut off. It should say domain and range. I underestimated how wide this was. All right, let's look at our first one. We got 0.8 here, 1.6 here, and it's exponential because there's an x for our exponent. What do you think a is? Well, a is 0.8. And remember, that's our y-intercept. So on our y-axis, we need a dot at approximately 0.8, which is really close to 1, which would be about there. Okay, b is 1.6. All right, since b is 1.6, do we have growth or do we have decay? We have growth because 1.6 is bigger than 1. So we got growth. So that means we need a graph that gets really close to 0 and then goes up. So I could draw it right now, but you know what? I like to be really, really precise when possible. So here's what I would do. I would get out my calculator. And I would click 1 for new document. If it asks to save, the answer is no. Then click 2 to add a graph. And let's type in this graph. So my graph is 0.8 parentheses 1.6 parentheses, And then to get that little x for an exponent, make sure you click the little caret. So click your caret and then click X and hit enter. Now this is great. So now I can see more what my graph would look like. Here's another trick. I just learned this pretty recently myself. Click Control, then click the letter T. And look, you'll have a table. So now we can plot some more points. So for example, I need a point at approximately 2, 2. And another point at, say, 6, 13 and a half. So that's going to be really close to 6, 14. And that's a more precise graph now. Let's connect our dots. So now we connect our dots. And remember, it's going to get really close to the x-axis, but never actually touch. There we go. That's a pretty good graph. I could have done better, but not so bad. Okay, what do we say the domain always is when you're in Algebra 1 and we're talking about exponential functions? Domain is always x is in the set of all real numbers. And what's the range? Always for exponential functions in this class. Y is greater than 0. All right, let's do one more. So we got 12.7 to the x. So what's a? A is 12. And what does that tell us? Well, that tells us the graph crosses the y-axis there. So that's our y-intercept. So on our y-axis, put a dot at 12. Okay, b is 0.7. So since b is 0.7, do we have growth or decay? We have decay. So that means we're going to have a graph that goes like this. But again, I like to be really, really specific and accurate, so I'm going to put this in my calculator. Okay, if you want to get rid of this graph, or sorry, this table, all you got to do is, again, Control T. And now, no table. All right, I want to change what I graphed, so just hit Tab, then up, and now I can change it. All right, this is what I want to graph. So I hit Enter. And hey, look, we were correct. It goes down. And again, hit Control T, and we can see some points. So I need a point about at 1, 8. And let's see, another good one is at 4, 2.8. And 6, 1.4. And 8.69, so. And that's plenty of points. So now just connect your dots. Mine touched the x-axis and that's no good. Okay, there we go. Okay, what's the domain? Yep, domain is always x is in the set of all real numbers. What's the range? Range is y greater than 0. All right, you have a practice page that has this and some labeling. Start with number 9 on your practice page just so I can see that you can do this. Then you can go back to number 1. Let me know where I lost you, where you have questions. I'm here to help. Best of luck.